of the costs, at least here in upstate New York, I believe, are some of the numbers. I mean, we are going to see some more numbers later on in the discussions as we move forward. But I wanted to just leave this here as a seed for you guys to start thinking about what you're looking at here are costs for just the balance of system. So, and I think Secretary Chu has said it in the summit also, that the DOE organized it. If you had the PV system for free, this is what it's going to cost you to actually implement PV, right? So it's upwards of $3 a watt. And that is definitely unacceptable as it relates to trying to implement PV and establish this ecosystem that I'm talking about. And this is where we also start to need to target our focus in terms of reducing costs as well. Again, I mean, people are going to, I know people are going to maybe agree or disagree with some of these numbers, but this is something that is still a high value content that needs to be addressed. With that, just with that very quick introduction, what I want to do is move us forward and introduce you to our next speaker, who is Min Lee. Min is the Chief Engineer of the Solar Energy Technologies Program with the Office of Energy Efficiency and Renewable Energy, where he helps manage and balance the portfolio of research, development, demonstration, and deployment programs in achieving our national SunShot goals. Prior to his current role at the Energy Department, Min spent his career in industry developing technologies and scaling new technologies to high-volume manufacturing. Min earned his BS and MS degrees from MIT, where he held fellowships by the Department of Defense, Department of Energy, and the Bose Foundation. Min.
Good morning. So I'd like to talk to you today about efforts at the Department of Energy to help revitalize American competitiveness in solar energy technologies. So we started planning for the SunShot Initiative about a little more than 2 years ago. And back then, Secretary Chu challenged us with the thinking, how do you drive renewable energy costs to the point where it's cost competitive with conventional forms of energy generation without subsidies? And so if you look at the unsubsidized cost of solar energy versus the cost that consumers pay for conventional forms of energy generation, what you find out is in 2010, the cost of solar energy unsubsidized would be roughly 4 times that of conventional forms of energy generation. So how do we drive this down by roughly a factor of 4 for 2010 baselines to about 5 to 6 cents per kilowatt hour by the end of the decade? And so, so borrowing a lot of the inspiration from President Kennedy about landing man on the moon by the end of the decade, Secretary Chu challenged the team with the thinking, how do you use technology? How do you implement cost reduction programs that can drive the cost and improve market share for U.S. companies and market deployment in the United States? This is a very challenging and ambitious goal. It's audacious, in fact, to think that technology costs can come down that rapidly. But then again, we're here in Albany, upstate New York, region of high-tech enterprises. Many of you work in the semiconductor industry. I know I did a decade ago. And you can see progressions in terms of improvements in performance and cost by orders of magnitude, over many, many years. And so this is the kind of learnings that Secretary Chu challenged us to do. Think, how can you get away from the existing paradigm and significantly reduce cost? Well, it turns out in order to do this, you would need to have PV systems at the utility scale cost roughly $1 a watt DC. Okay, $1 a watt is a nice round number. It translates to roughly 5 to 6 cents per kilowatt hour at the utility scale. And in order to do that, modules would need to sell for roughly 50 cents a watt. Now, please remember, in 2010, the cost of modules at the global average selling price for PV modules was close to $2 a watt. Okay, and to think that innovations can help reduce that cost by a factor of 4, in a matter of years is a really challenging goal, especially when you look at history. Well, this is a trend chart on a semi-log plot, somewhat similar to Moore's law, where you look at the cost of PV modules over the past 30 or so years, starting from around 1980. The cost decline in PV modules was roughly 20% or so for every doubling of manufacturing capacity, and this is plotted on time. So when we looked at these trajectories, these trends, it would seem like in order to hit 50 cents a watt, it would take all the way out to 2030. And so the world government is a challenge and push technology even faster than that. So, in order to achieve 50 cents a watt, we looked at, can we do this by 2020? Guess where it hit this year? Okay, we're off the curve. We're off that trend line. Market forces, of course, is the biggest cause for this significant change. PV modules today, you can buy for less than 80 cents a watt. Okay, 80 cents a watt. Just imagine, a year and a half ago, it was more than twice that. In 2008, modules sold for $4 a watt. Okay, today, 80 cents a watt. Very dramatic changes in the average selling price for PV modules. Of course, this is creating havoc across the manufacturing space. Our industries in the US can't respond that rapidly to such dramatic price changes for a commodity product. And so, so there is very significant forces at play right now and in an oversupply situation. But that also tells us that there's actually hope that we can achieve modules at very close to or even below 50 cents a watt in a number of years. And there's certainly some exciting technologies in the Department of Energy's portfolio that I have high hopes for. So, but it is more than just the hardware cost. It's more than the module cost. When you look at the homeowner, the average homeowner across the United States is paying something close to $6 a watt, $5.70, $5.80 a watt to put PV on their home. Okay, where are these costs? Well, the costs are in a number of different areas. Number one, power electronics is one factor in the cost. And at the DOE, we develop programs, funding programs, to help universities, national laboratories, small businesses, large businesses innovate. And these are funding programs such as the Solar Debt Program run by RPE or the SunShot Incubator Program. We also work on innovative ways to reduce the balance of systems hardware costs. You know, these might be racking systems, more mechanical systems, and how do you use technology to simplify the installation of PV modules. We also work on soft costs, and this is actually where the focus of this conference here today and tomorrow is around how to reduce the soft costs associated with PV installations. And the conventional technologies or the conventional ways that the Department of Energy and the U.S. government works with in partnership with industry, academia, and national labs is to fund research at the earliest stages of development to improve the performance of the technology, from the efficiency of solar cells, driving the performance up, and of course the manufacturing costs, and this is a very important part, driving manufacturing costs down. It's not just all about being in the science labs. A lot of the technologies happens on the production floors. How do you improve the utilization of your factory to improve output, because that actually has a humongous impact on the actual cost that manufacturers can make things for. And of course, the semiconductor industry, we have a lot to learn from that industry in terms of improving factory performance. So our targets at the residential scale are a little bit higher than that at the utility scale, because residential homeowners pay a much higher rate than the wholesale rate of electricity. So our goals at the residential scale are to have systems sold for approximately $1.50 a watt. And now keep in mind that price target is actually quite aggressive, because you don't actually need to hit $1.50 a watt in order to have solar to be cheaper than than the retail rate in many regions of the country. For example, today in Hawaii, if you put solar on your rooftop, it would pay back for itself very quickly. In New York State and Massachusetts, where I live, the retail rate of electricity is close to 15, 16 cents a kilowatt hour. Okay, that's actually much higher than the national average of about 10 cents a kilowatt hour. So, our targets here is actually not just to have certain regions of the country, not certain states of the country to be cost competitive with solar energy, but to have solar broadly competitive across the United States. So I do want to point out here that many of you know Germany is the world market leader for the deployment of solar energy. And Germany has as much sunlight as Alaska. Okay, so think about that for a second. There's more solar deployed in Germany than any other country in the world, yet Germany has the same solar resources as Alaska. So why can't we have more solar energy in the United States here? Okay. So significant cost cost reductions, of course, have happened already just in the past year and a half, 2 years. At the utility scale, when we were benchmarking the cost of utility scale solar power plants in 2010, it was somewhere between $3.80 to $4 a watt. And in just 1.5 years or so, the costs have come down very dramatically, down to between $2 and $2.80 a watt in just 1.5 years. So this is really exciting, and it gives us hope that we can achieve $1 a watt by the end of the decade. So the United States is actually a great leader in terms of innovation. We have some of the best research universities in the world. Here, in Albany, out in the West Coast, Stanford, Berkeley, Caltech, MIT, Purdue. I mean, we have some of the greatest researchers, research universities in the world. They're funded in large part by the U.S. government, by the taxpayer,